Hello everyone, hope you all are well. So before starting the numericals related to concentration terms, first we will discuss some small concept related to molarity and normality. The first one is dilution equation. Dilution basically it means when we dilute any solution, means when we add more amount of solvent. Suppose we have a solution 36 normal and we have to make 0.2 normal solution of 100 ml. We have to make 100 ml solution of 0.2 normal normality, but we already have the solution whose normality is 36 normal. Then how we can dilute? We can dilute by using this equation, N1V1 equals to N2V2. Here this N1V1 is for the concentrated solution, means which is already given, and this is for diluted solution in which we have to add water, means this one. So on putting these values, here N1 is 36 multiply this volume. We have to calculate how much amount of this solution will be added to make more dilute solution. N2 will be 0.2 normal multiply here volume is 100 ml. On solving this equation, you will get the value that how much amount of this solution you have to take. 100, 36. If we had point 10 piece of 10, it will become 0.55 milliliter. So this much amount of this solution will be required to make this normality of solution. So this is the dilution. Here we have the concentration 36 normal. 36 normal. To make this concentration and the amount of solution is this, we have to take only this much amount of solution. So this is called dilution equation. Let us consider it's one question. Now focus on this question. What volume of H2SO4 is required? So we have to calculate volume of, let's suppose V1 is volume of H2SO4. Now required to prepare 250 ml of 0.1 normal H2SO4. This means V2 will 250 ml. If V2 is 250 and N2 will be 0.1 normal. V1 we have to calculate. We already know the normality of this H2SO4 is 2 normal. So this will be the actual normality of this solution, 2 normal. So N1 is equals to 2. Now, by applying the equation, N1V1 is equals to N2V2. This is the value of H2SO4 and this is the value of 0.1 normal H2SO4 which we have to make. So 0.1 multiply 250. Here N1 is 2 and V1 we have to calculate. So V1 we get 0.1 multiply 250 divided by 2. Here point can be removed. This will become 12.5 ml. So in this way you can use this equation. This equation is called dilution equation. Normally it is used in the practical purpose when we have to make the less concentrated solution from the given solution. Next category we have to discuss, that is mixing of solution. If we mix two solutions, then how we calculate the normality of the resulting solution, molarity of the resulting solution? Let us consider one example. If we mix HCl plus NaOH, this is the first condition. Second, HCl plus H2SO4, and third, NaOH plus. Now observe carefully. This is acid This is also acid. This is base and this is also base. For these reactions, we will apply the normality equation N1V1 plus N2V2 equals to N3V3. And molarity equation will be M1V1 plus M2V2 equals to M3V3. So when the nature of both the liquids which we are going to mix is same, then there will be the positive sign. Now, if we consider this case, here it is acid and this is base. Now, if the nature is different, then the equation will become N1V1 minus N2V2 equals to N3V3. M1V1 minus M2V2 is equals to M3V3. This N1 and M1 is N1V1 is the normality and volume of this acid, and this N2V2 and M2V2 this is the normality and molarity of this base. And this will be the normality of solution and this is the molarity of solution and this will be the volume of solution. So let us consider one numerical problem related to it. Here we have to calculate the normality, but in this question here molarity is given. First we have to convert this molarity into normality. We know that normality is equals to N multiply molarity. This NaOH base this is a base and acidity for this is 1. So 1 multiply what is the molarity? 0.1. So normality will also be 0.1. So now we write the values. N1, this is N1, N2. This is N1, 0.2 normal and N2 is 0.1 normal. V1 is 100 ml and V2 is 50 ml. V3 is 100 plus 50. This is 150 ml and we have to calculate the normality of the resulting solution. Now apply the equation N1V1 N2V2 is equals to N3V3. Now here I have to put negative sign or positive. For this we have to check. This is an acid and this is base. The nature of both the substances is different. So we put negative sign here. By putting, now substitute all these values. 0.2 multiply 100 minus 0.1 multiply 50 which is equals to N3 multiply 150. Now solve this equation. Now it will become 2 tens are 20 minus 5 and 3 multiply 150. It will become 15 divided by 150 and 3. So N3 will be 0.1 normal. So this is the way to calculate the on mixing of solution. Now if we consider another situation in which the nature of both the substances is same, then how we apply this equation? Now see another question. Here the nature of both the substances is same. Both are acids. Now we have to apply the equation N1V1 plus N2V2 equals to N3V3. First you have to write the given things. Then you have to apply the equation. First N1 is 0.2 normal multiply V1 is 100 plus. Here N2 is 0.1 multiply V2 is 200 and 3 we have to calculate and V3 will be V3 is equals to 100 plus 200. This will become 300. So V3 will be 300. Now on solving this equation, what you get? This will become 20 and this will again 20 and 3 multiply 300. This will become 40 divided by 300 which is equals to N3. This will become 4 divided by 30 which is N3. On solving 0.109 normal. So this will be the final answer, normality of the solution. Now let's proceed further one or two numericals. Now see this question. We have to calculate molarity and normality. First you have to write what is the given. 0.5 gram of weight of solute. This is 0.5 gram. In 5 volume of solution is 500 centimeter cube. We can also consider it as 500 ml. Now molarity, the formula of molarity is number of moles. We can write number of moles as W2 over M2. This is number of moles, multiply 1000 if we consider volume in ml. Now on putting values, W2 is 0.5 gram. Here M2 we can calculate. Molar mass of sodium is 23, oxygen is 16 and hydrogen is 1. On calculating you will get 40 gram per mole. Here we put 40, multiply 1000 and volume in ml is 500. Now on solving, what you will get? This will become 1 divided by 40, which is equals to 0.025 molar. This will be the molarity. Now we have to calculate normality. There is a two ways. By using this molarity, we can also calculate. We have the formula N multiply M. This N means here this is a base. The acidity of this sodium hydroxide is 1. So 1 multiply 0.025, it will become 0.025 normal. This is the one way to calculate normality. Another way you can calculate the equivalent weight. If we calculate the equivalent weight of this, it is again 40 by putting in normality equation, which is given mass upon equivalent mass multiply 1000 divided by volume. 0.5, as this compound has same equivalent mass and molar mass, so its value remains same. 1000 divided by V is 500. So on solving this, it will become equal to this value. So in this way we can calculate the molarity and normality. Now that's all for today. In the next video we will discuss certain more types of numericals related to this concept. Thank you and have a nice day.